Good morning, everyone, or good afternoon, depending on where you are. Welcome to today's webinar. It's going to be on earthwork optimization for rural infrastructure projects. I'm Erin, the Business Development Manager here at Softree. And for those of you here in the live version of the webinar, I encourage you, please, ask questions, engage with us through the Q&A section of the GoToWebinar panel. We will tackle the questions, most of them at the end, and depending on if we've got have a bit of time during an optimization, might tackle a question there as well. So to get us started, I wanted to do a little bit of an introduction just to what earthwork optimization is. So let's get started. So first off, today we are going to be demonstrating earthwork optimization through our patented Softree Optimal technology. This is either an add-on to our civil design software RoadEng or available as a standalone software tool. The process itself is mathematically based, and it helps you to determine the lowest cost alignment, which satisfies your constraints and standards. These could be K-value, min-max grade, a whole bunch of different options. So it will look to mathematically, minimize those earthworks and deliver the lowest cost alignment. It's turning road design into a semi-automated process. As Matt's going to show you, there are still a few things that you as a user need to do to get it set up, but then there is definitely a button you just get to press and it runs for you to minimize those earthwork costs. Softree Optimal and earthwork optimization are really not well suited to urban projects. If you have a road project or a corridor project that is overly constrained, Softree Optimal is not that effective. But it is best for projects that have some ability to move the vertical or the horizontal alignment. So, for new builds or realignments, this is where the software tool can deliver some really amazing results. There are two different types of optimization. So first we have vertical optimization, and this delivers a true mathematically optimal solution. Your earthwork loading costs, embankment and excavation costs are very much defined variables, and we can deliver a specific mathematically true optimal solution. Whereas horizontal optimization is going to search for a better alignment within a user-defined corridor. Horizontal optimization uses vertical optimization repeatedly and can actually take a while to process. But more than anything, earthwork optimization is a tool you can use as a sanity checker on your projects and your designs. Now, vertical optimization itself has a few different variants, and this is a point of confusion, so we're going to go through it a little bit here together before we pass it over to Matt for the demo. So there's 5 different vertical alignment types or variants that can be generated by Softree Optimal. Now, the first of these is called polyline. There are no curves, it is exclusively tangents, and understandably, this is almost never used. The next option is called curves fast. It typically produces the lowest cost solution of all of these options, but it produces a very bumpy road. And this is because it can include back-to-back curves. From here, we have another option called curves and tangents. It's a little bit slower to process, a little bit more expensive, but will still deliver cost savings, obviously. All of these will. It has a minimum tangent that's defined between the curves, and that tangent is of a fixed length. The next one, which is a little bit slower still, but it is usually the smoothest option, and that's variable curves and tangents. So in this case, optimization will look to produce an alignment that has curves and tangents of varying lengths. And so that's why it takes a little bit longer to solve. The last option is user-defined. So this is where Softree Optimal is going to look at any curves that you have defined in your original or current alignment. It's going to preserve those, not add any new curves, and just move the vertical IP points up and down to fine-tune the optimization and to minimize your earthworks. So today's webinar is going to focus on the process of optimizing through these different options. And I should mention the savings and length of time it takes to solve are very much dependent on your specific project, how constrained it is, and truthfully, most importantly, how good the engineer did with the original design. But in today's webinar, our starting point is a rather reasonably designed project at 858,000. From here, using our original user-defined curve positions, we can quickly shave off 3% in our subgrade earthwork costs. And yes, it does sound rather unimpressive. When Matt told me the number, I was like, oh, that's it. And he was like, yes, but that was $20,000 in 2 minutes. And more so than anything, that's a huge sanity check for the engineer and their design. The other options, I'm just going to quickly fire them up here on the screen. Oops, too far. Yeah, produce very different savings. So when we start to let the software define where the curves are and the tangents of variable lengths, we're looking at 7%, which is 60,000. Curves fast, that's our super bumpy road option. 12% savings from our 858, so that's about 100 grand. And then with horizontal, now this takes a little bit longer, and Matt's going to do it through a cooking show approach, which means he's going to show you how he sets it up, and then he's going to basically pull it out of the oven in a different window of our software, because it does take about an hour or so to solve. By optimizing just the horizontal position of one IP, we're looking at about 18% savings, and that can be, extended even further if we were to go across all the IPs. So with that kind of long-winded intro, I am going to pass it over to Matt, and yeah, let him take you into the software. And as I said, please do ask questions and engage with us through this. It definitely adds a lot more value to you as a viewer.
All right. Thanks for the introduction, Aaron. Yeah, and we'll jump right into it. Before we get into the optimization, I am going to just start from scratch and build my tin to design with, and we'll set everything up from scratch. I won't put too much emphasis on what we're doing there from the starting portion, so bringing in LiDAR data, etc. But we will just show the process if you're entirely new to the software. Yeah, and then this is working strictly with the RoadEng software, not as a standalone. So if you were working with a standalone with other softwares, you could use a land XML surface instead of one that we create in Terrain. So I'm going to start by opening up Terrain, and the software is modular. So we're going to build our topo surface in Terrain, and then we're going to do our design and location. So here, since I'm working with LiDAR data, I want to add a feature to my data based on. So I've got a preliminary alignment. I don't care about stuff a long ways away from it. So I am just going to grab the LiDAR data that's within a certain distance of my preliminary alignment. So let's set that corridor width at 400 in this case. And we'll hit OK. So LiDAR data is being brought in. We'll have a bunch of points. They're going to initially show up. I'm going to click off to the side so they're not displayed. We don't have a surface yet, so I'm just going to click terrain modeling. I'm going to generate a surface. And while we're in here, I'll generate contours as well. Now, we could, once this is done, we'll hit save, and we could work with that. Now, since I'm going to cover, as Aaron said, the cooking show approach for the horizontal optimization, one thing that comes up is, well, if I know I don't want to go to a certain location with my alignment, how can I constrain it so it doesn't go there, aside from just setting the variance for how far it can be adjusted? Well, we can trim the surface so it doesn't want to put the alignment where there's no surface. So if we click the 3D view, this will just take a minute to calculate. Not a minute. We can see we've got some fairly steep terrain here that I know I don't want to get into. So I'm just going to trim my tin, and you can do that entirely by hand, making your own feature. I'm going to create a tin boundary. I'm going to use that boundary feature as a starting point. And I am going to just recalculate by hand. I'm just turning this on so I can see where I'm at in the two views. I'm going to click this in here. So I'm setting a boundary for this, and that's that. So now to get rid of that other surface, I'm going to, so when we brought this in, I've thin based on a feature. I'm going to thin based on a feature another way here. I'm going to remove all the points outside of this, and I'm going to recalculate my surface. And if I wanted to, I could just set that as thin boundary and recalculate, but this keeps things pretty concise. We'll get rid of any extra data outside of the area that we're interested in. All right, there we are. So I'm going to hit Save As. So we've got our surface. It's ready to work with. Let's call this topo. So we've got what we need to design and train, or to design and location. Now another thing, if you happen to have a preliminary alignment that you want to work with, in this case I do. So say we did a field review, I had a rough idea of where I wanted to place my new alignment. I can bring in my P-line. So I'm just bringing that in as its own feature. I'll save that, and I can use this as the basis for starting alignment and location. It's an option. You can also start from scratch and click everything in manually. Did I hit save? All right, so into location. So here we're going to go new. We're going to set our target as the topo surface we've just created. So here, if we wanted to have an alignment based entirely on something that we click in the location module, we could start with a single point. Since we've added in that preliminary alignment we want to use, we can reference it here. Ta-da. So there we can see our preliminary alignment. So that feature that everything's based on is visible. Our profile isn't, it's just showing us a draped elevation profile. So topo surface is equal to our center line along this. And the traditional approach for designing would be to come over here. Well, first let's add in some curves. So let's go with a design speed of 60 kilometers an hour. We'll hit apply. So I'm adding in a horizontal curve. And I could go through and I could add in horizontal curves at each one of the IPs if I'd like. I can use different types of curves if I'd like. So 120, I could set that to whatever radius I like. I could use a spiral curve instead, etc. I think for this example, 60 kilometer minimum radius 120 works quite well. So we'll just apply those to all of our IPs. So I'm just applying 120 to the default. And there we are. Oh, I've got something funny going on over here. Yeah, we'll fix that as we get going. Yeah, so we've got a horizontal alignment clicked in. Well, the original was this from the shapefile that I've added, and then we've added curves to it to keep it pretty. For our vertical, the traditional approach would be to click in an alignment by hand. Everything's updating in real time. We can see our mass haul. We can see how things are being affected as we move things around. And we can come back here to the vertical curves tab and add our vertical curves. So go with 18, a K value of 18 for these ones. And we can move these around a bit more as well. So here we can pull this up. We've got a surplus. And there we're close to balancing, so we'll use that as our baseline. So how much is this going to cost? So this is the traditional design. We can go over here, recalculate recost, and we can quickly get a total cost populated over here. So what's driving that total cost? If we click the ground types, come over to costs, we can see that we've got costs assigned to execute different types of earthworks. So in this, we've got a handling cost for our different material types. I've only got the default material types assigned along the length of our road. And we're saying it's going to cost $12 a cubic meter to excavate, $4 a cubic meter to place. And for movement, we've got our mass haul diagram where we can add unit costs for the movement of materials. So that movement is shared amongst all the materials, whereas the handling cost is unique to each material if you'd like it. And you can add as many materials as you'd like. Yeah, so we're at roughly 1 million. So we've got units of thousands of dollars. And yeah, those numbers that Aaron gave off the start, they were representative of the cooking show approach that we'll go to. So once we do an optimization here, we'll jump over and go with the files that are already prepared. So to optimize our vertical alignment, we can click in the Project Explorer window, Vertical Optimization. This first tab, we're just going to set up for how the optimization takes place. So the software is going to figure out a bunch of different cross-section possibilities based on sampling the alignment at certain intervals and then applying those cross-sections at different elevations. So here we're saying let's sample the alignment in 20-meter intervals, and let's allow the finished grade to be 10 meters either side of our preliminary alignment, which we have here. And before, let's do a new one so we can keep this alignment that we have designed and compare it to something new. So there'll be multiple vertical alignments attached to the same horizontal alignment. For standards, Aaron introduced the curves. So we can use a bunch of different options here for the way the vertical alignment is going to look when we're all done. So if I use fast curves, we're going to have a bunch of curves butted up against each other. User-defined curves, we just move around these curves that I've already applied. And variable and curves and tangents are going to have a tangent in between our vertical curves. So let's use variable curves and tangents here. I'm going to set it so we have a minimum tangent length of 60 and a minimum curve length of 60. We can assign our grade constraints, so we'll leave it at the default for have a 10% grade in either direction. I'll keep it a good comparison to the alignment I have clicked in there. We'll keep it at 60 kilometers an hour, so K's of 18. We'll hit add edit. Control points. This is a realignment project, so we will add a control point at the start of our alignment. And let's control the grade there as well. So here we want our grade to be 1.3% coming into it. And let's add another control point at the end of our alignment. And Let's add a grade constraint as well, and if I remember correctly, I think we want to be at 0.6. Pits, we won't worry about pits for this one. That's just if we are able to borrow material along the length of the road, we can account for that and figure out which pits we want to open. Same with waste sites as well. Unit costs we've already talked about. Constraints, we'll leave this to the default settings. Most cases that's appropriate, but if you have something special you want to capture, like controlling material movement in a certain direction, so I only want to move material along this first 600 meters backwards. So if it's a dozing job, it's always nicer to move material downhill for productivity. You can account for that and just say from station 0 or ... to 600, we want to move our material backwards. Sidecast is a linear spoil site. Minimum fill, if you have certain sections where you want to have the embankment a certain height, you can capture that as well. And same with full bench or minimum cut. Optimization, actually these last 3 tabs, I don't see any reason in really messing with them ever, so we'll just leave that be. So we've set it up, we haven't actually done anything yet. So we'll click this guy, we'll click vertical optimization, and we'll click process. And right now the software is going through and it's doing that sampling along the length of the road, and then it's going to actually solve for a better vertical alignment. While it does that, we probably have some time for a question or two.
We have a quiet audience today, Matt. We don't have any questions. Oh, wait.
Yes, we do.
Just one. Great.
Okay.
Our question that just came in is, can you account for paving costs?
Yes, you can. So there's a couple different ways you can do that. I'll explain it a bit more here once we've finished calculating the optimization. But by default right now, it's just optimizing the cost for subgrade construction. So that's, in most cases, if you're looking to optimize your alignment, that's what's variable. Usually your road's a set width, so you don't, from figuring out the best vertical alignment, you don't really have to account for those fixed costs. But if you're looking for that for costing the project, you can add it in. And we can do that by assigning different materials to the different layers in our roadway and capture it that way. And we can also do it by adding in custom attributes, and we can also do it by, especially with the horizontal optimization, just assigning a fixed linear cost for the road. And we've got the chime, so we've got an optimized alignment. That looks good. We can see the cost went from being just over $1 million to 800,000. And there we are. So here we've got our curves. We can see our mass hauls balanced. Everything's looking good. And just to show how the, where is it? Variable curves and tangents up here. I'm going to turn on some labels here, and it's going to get a little more cluttered. But we can see the beginning and end of our curves a little bit better, so we can see we've got tangents between our curves. So that's reflective of the standards that we've assigned and the type of curves we're using. So we've covered how to set it up. Usually the variable curves and tangents, as far as the vertical optimization goes, it takes the longest to solve. So as you can see with that, it solved in 4 seconds. The sampling is what took the longest in that. So let's jump over to a prepared one. So with this, I've gone through and rather than watch me change the variables and click and recalculate, I've gone through already and I've done a few iterations. Largely the same road, and let's just look at what I have here. So my first alignment, I'm just going to recalculate, is the one I did by hand. These numbers will reflect the numbers that Aaron gave in the introduction. The second alignment is the one where I used user-defined curves. So all that did, it took the curves that I've assigned in there and it's moved them up and down. That hasn't shifted them in either direction, and it hasn't added additional curves. So it offers some savings, and as Aaron said in the introduction, it's not super impressive for this one. If you look at, oh, you only saved 3%, but it was the matter of coming in here, setting this to user define and adding in my parameters and hitting OK. And then it went actually faster than that last solve that we did live, and we've saved 20,000 right there. And we also get, if you're an engineer that is very particular on where things go, whether it's just a personal preference or the project demands it, you get a lot of control for how things are going to look that way. So, and we shaved off $20,000. Then I went in here, and this, I believe, is the variable curves and tangents, which I just did. Yeah, so that's the same as what you've seen. And then we have the fast curves. So here we can see we've got a lot more curves, and they are butted right up against each other. So depending on your application, this might not be favorable for your project. Oftentimes, if you're dealing with high volumes, high-speed roads, you probably want to avoid having vertical curves butted up against each other unless you have a much longer or a much larger K value than your minimum design parameters. So yeah, that's the vertical optimization in a nutshell. And then let's talk about the horizontal optimization. So here, if I've clicked in an alignment and oh, and I should mention too, before I talk more about the horizontal optimization, with this vertical optimization, it can be generative. So in the case that we've just gone through, I clicked in a preliminary vertical alignment to use as a baseline. And for this purposes of this, it was more to give us numbers to compare. If you're just starting a project out from scratch and you're using the vertical optimizer, you can set this vertical band center to ground, and then your vertical controls for your offset, well, that's 10 meters of cut, 10 meters of fill, and it can generate an alignment right from scratch for you without having to do any clicking around in your profile. Now, let's jump to the horizontal optimizer, and it doesn't work that way. So the horizontal optimizer will work by adjusting your IP location. So if you don't have an existing IP to adjust, it can't do anything. It also won't adjust your beginning and end of your alignment. So your POC and POT are fixed. So let's assume that we've got this project, we're fairly happy with it. I'm just going to add in an extra IP here. So I'm giving it an extra IP to move around. I can come in here, I can click new horizontal alignment. I can duplicate the one that we've already started out with. So that's a complete duplication. We can come in here, horizontal options, and optimization parameters. So here, we can set the limits for optimization. So if I want to let this optimize in, let's go 100 meters either direction. We'll hit OK, and we can choose which IPs we assign that freedom to move around to. So let's go with IP7. And that's showing us that, okay, we can move IP7 around here. And actually, I meant to do IP8, one that I just, or IP6. There we go. We can move that one around if we'd like. And then to actually run the optimization, we go to horizontal optimization, hit OK, and it'll run. Now I hit cancel just because, as Aaron said as well, that typically takes a while longer. So for this example, I've already gone through the process and I've run it. So that it was originally up here, the IP that I've allowed it to move around, and I've run it, and it took our original cost for this one of just an apples to apples comparison of $857,000, and we've got that down to 704 just by letting it move one IP. And that's using the, since it's built on the vertical optimizer as well, that's using the variable curves and tangents option for that optimization. So pretty significant savings, and you are not limited to just optimizing one IP. Truth be told, when I did this, I was kind of left it to the last moment, and I just chose one IP as an example to make sure it was calculated quick. That optimization for one IP took a bit over an hour, I believe. And then I did run it for the full data set, but I didn't hit save. And that took 2 hours to optimize everything else, which it's not necessarily a linear function. It just depends on how the topography interacts with the road for when it's solving. So that's optimization in a nutshell. If you're using it as a standalone software, you can export your data set. So we have save as. We can save it as a bunch of different formats, including DWG and LandXML, DXF, DGN, etc. You can use that with another software. If you're looking to do a finalized design, we've got our own multiplot in this, and we can read in a pre-formatted workbook to really expedite the process. So there's our design, plan profile chapter, and then cross-section chapter. So just like that, we've got a design from start to finish with optimal earthworks.
Awesome. Thanks, Matt. So if you have any questions on today's webinar, and I see a few of you have already input those, feel free to type them in. We've got a couple minutes we can hang around after, I should say, because we've gone over time, we'll hang around for a few more minutes to answer some of them. So one of the questions we've got here, Matt, is can you change the cross-section geometry, or are you stuck with whatever the default parameters are?
Yeah, you absolutely can. So you can change a lot of things with the software. It's quite powerful. Let's just zoom in here. We can take this. So this is the default cross-section template. The templates, so this is kind of a CAD equivalent to an assembly. We can open them up. The templates are a collection of components. So here we've got a rural road component. It's highlighted in magenta. Double click that, and I can adjust the values for it to change the different parameters. So here, if I want to go with a 4-meter width on the one side of my road, I can change that, hit OK, and it updates. If the geometry you're looking for is not captured in one of the default templates, we've also got an e-library which carries a bunch of these template components, and you can combine those and get whatever cross-section geometry you're looking for.
Awesome.
Right.
So we have a couple more questions, and I'm going to go kind of out of the queue here because they're related to cross-sections. So the first is, can I import my cross-sections from another design software like Civil 3D?
Yes, you can. I am not super savvy on the workflow for that. There is an extension, I believe, for that, and it'll give you an approximation for the to talk between the two formats for how that assembly behaves in one software versus ours. Aaron, you might be more familiar with that than I am. Is that a,
Maybe. We do have a resident expert in-house at Software who, yeah, does a lot more work with Civil 3D, but we have, I believe it's a plugin called Export Corridor. It creates something called a CSX file, which samples your cross-sectional behavior in your assembly, I think plus or minus kind of 10 meters or whatever you define, and then we can bring that series of behaviors into the software so that as the optimizer moves it around, it has an idea of what the cross-section is going to look like at those different positions. We did have one more question here on cross-sections that we could probably tackle in this kind of group, and then, yeah, we'll maybe do one or two more after that. Can you have multiple typical sections through the corridor?
yep. So yeah, absolutely. So with this, say for example, I've got my rural template assigned, and it's a pretty drastic example, but I just happen to have an urban example here. So if I wanted to go from my rural to my urban template, the templates themselves get assigned and assigned by range. So here I've got rural, and I can assign from rural to, so let's go station 1000. Actually, that's already there, so rural's already assigned, so I don't have to reassign it. And if I want to go from urban to the end of my alignment, come in here and click that. And if you're jumping between a bunch of different typical cross sections, you'll obviously some things will be out of date there. We'll have to re-optimize our alignment. But here we can see we've got the urban, whereas if we go back to that before the change takes place, we've got the other template assigned. And there's more functionality than just that as well. You can assign different templates for either side of the road respectively. And you can add a lot of logic in some of these templates as well to capture smart behavior depending on the circumstance. Let's see if I've got a example here that I can show you something that's reasonably smart. So here with our mine road template, oftentimes you'll have a safety berm requirement if you're over a certain fill height. Well, that's going to look and probe and see that, okay, we want to actually change our geometry because certain conditions are met. Let's add in the safety berm because we're over the threshold value that's assigned in here, so 3 meters in that case. So yes, should be able to capture a bunch of different behaviors that you're looking for.
Awesome. I've got a couple more here that we can tackle. And we did this next question, we addressed it a little bit, but I think it's good to ask it explicitly like our user has said here. What kind of optimization curve or variant should I use? Do you have one to start with?
Oh, so kind of like which of these, no, actually, let's make this bigger. Which curve type to use? Alluded to it. It'll depend on your project. Just giving examples for all of them. The polyline application, it doesn't get used a ton for road design. Some of our clients that use the software for pipeline design, like the polyline option. Then curves fast. Typically for me, I'd use that if I had a low volume, low speed road that I just wanted to make as cheap as possible. So if you're coming from a resource sector, that would be your short lifespan, not a ton of use roads. Or if you have something that's you just need to keep it as cheap as possible, that would be the best fit there. Curves and tangents. So curves and tangents, personally, I don't use that one a lot. That'll give you a fixed length for your curves and tangents. It's somewhere in between fast curves and variable curves and tangents. Variable curves and tangents will adjust the length of your tangents and curve length to best suit your scenario. And I think realistically that's probably the most used and most practical for a municipal or a rural road setting. And then user defined is a good one if you've got something that the engineer or designer just wants to capture very specifically, where you want your curve to be here, here, and here. There's a little bit of freedom uh, for where that curve is located in terms of elevation, and that's a good one to use for that. So a typical example for that might be if you're dealing with bridge abutments, or you just want something that looks very specific if you've got you're worried about aesthetics and you want it to look a certain way.
Excellent. Okay, last question of the day, and then we'll let everyone sign off because we've gone about 10 minutes over. Where do the costs come from?
Okay, so the costs, that is a good one. The costs are user defined. For us, the default values in here, actually, I'm not 100% sure where they came from, but they are reasonably appropriate. So depending on your line of work, how you derive these costs might be different. A lot of times municipalities or governments have fixed rates based on cubic volume of material, so whether it's imperial or metric, in which case it's really easy. You just take whatever your contract price is and dump it in there, and you'll get a good cost. If you're dealing with something, if you're a owner-operator looking to design your own roads that you're going to build, in that case I'd probably derive these costs either based on historic data for how much specific tasks have cost me in the past, or base it off of production equations and rental rates. So, and if you're going that route, I always relied on the CAT performance manual to get reasonable cycle times.
I was muted there for a second and trying to talk. So thank you, Matt. I think that was a great introduction to like the different options for earthwork optimization. If you have any other specific questions, or if you want to see optimization on your own project, that is something that we do in terms of like a demo format. Please feel free to reach out to us. You can just go to softtree.com. Lots of different contact options there. And yeah, that's it. So thank you everyone for coming. Thanks again, Matt. I hope you all enjoy the rest of your day.
Thanks, everyone.
Thanks for watching another SoftTree webinar. Please be sure to subscribe to our channel below, or tell us that you liked the video. Thanks for watching.